As the electromagnetic spectrum continues to evolve with emerging threats, the congested and contested environments continue to drive the toughest requirements for all operations across land, air, and sea. New technology and sensors are driving test requirements to provide more complexity, fidelity, and greater realism for simulation and analysis. Reliable receiver and transmit technology in current and next-generation platforms are vital for successful operations. Success depends on rapidly adaptable test solutions for precise signal generation, capture, and analysis. As an industry leader in electronic test, Keysight Technologies continues to innovate and deliver the most advanced, scalable, and open architecture test and evaluation solutions.
Hi, I'm Chris Johnston, the Director of Keysight's Electromagnetic Spectrum Operations Test and Evaluation Group. I'm excited to talk to you today about the newest addition to our EMSO test and evaluation portfolio, our latest benchtop EW threat simulation solution. With the accelerating threat environment, continued improvements in test and evaluation are a priority here at Keysight. It's our mission to deliver solutions that validate protection and countermeasure systems against the toughest threats with the most stringent requirements. Keysight is working closely with industry leaders to provide test solutions that can be seamlessly integrated into their workflows so they can place their focus where it counts. Many are faced with the challenge of modernizing legacy systems and data, all while trying to stay within budget and meet tight timelines. Our cutting-edge EW test solutions are here to address those challenges. We are addressing these needs with Keysight's newest benchtop VXG signal generator. It's the industry's first multi-port source with up to 54 gigahertz of frequency range and 2.5 gigahertz of modulation bandwidth in a single instrument. With external upconverters, you can even achieve frequencies up to 110 gigahertz. New chip technology in the solution has enabled 3 very crucial advances to address EW test and evaluation requirements. First, the new proprietary custom chip technology provides unprecedented spectral purity using direct digital synthesis and digital upconversion to avoid false threat detection. Next, newly implemented correction filters allow for embedded phase and amplitude corrections across the entire 2.5 gigahertz IF band. This enables industry-leading signal fidelity and the ability for pulse-on-pulse simulations. And finally, wider bandwidths, higher density, and more instrument ports are some of the most in-demand product features within the industry today. Customers want more capability from a smaller, more compact footprint. The VXG addresses all those concerns with a multi-threaded chip which offers 8 baseband generators per RF output. This includes up to 8 pulse-on-pulse outputs or any signal type from any one of the individual RF output ports. Keep in mind that this instrument can be equipped with up to 4 output ports on a single unit. That equates to densities of up to 32 different signal types. Imagine having the ability to use one generator as a 4-port angle of arrival benchtop simulator. The VXG makes this vision a reality. Our solutions are addressing signal density requirements with the ability to stream well beyond the current industry ranges of millions of pulses per second on any RF port. As test requirements change, you can also synchronize multiple instruments for even more density and ports. This exciting new addition to our EMSO portfolio complements many of our other test solutions, including Keysight's EW threat simulation software. That software enables dynamic threat simulation with a flexible, open software architecture. On the receiver side of our portfolio, the UXR multi-channel phase coherent analyzer is an instrument that can evaluate various threat detection and prevention systems like radars and jammers. It provides up to 4 RF analysis ports in one single instrument. We've now combined variable width segmented capture together with real-time digital down conversion, which makes it possible to capture and analyze every radar and jammer pulse in a typical EW scenario. Together with the VXG generator, you can create, generate, and analyze the most complex test environments from benchtop verification, system integration, installed system test facilities, open-air test ranges, and mission data validation. Keysight is excited to lead the way for this next generation of EW testing, no matter the environment or test requirement. Our industry-leading scalable architectures, compact footprint, and open software interfaces save you time, space, and budget while providing unmatched quality, service, and support. Let me pass it over to Vante Stewart, our technical marketing engineer, to demonstrate these new capabilities.
Hi, I'm Devontae Stewart, a technical marketing engineer here at Keysight. Today, we're going to go through a few demonstrations with our EW testbed. I have Keysight's Simulation View software, which is streaming real-time signal descriptor words, SDWs, to the 4-port VXGC signal generator. The output is connected to the UXR multi-channel phase-coherent pulse analysis oscilloscope with the VSA pulse analysis software. I'm using the Simulation View software to create a multi-emitter threat environment. The Simulation View software is an open architecture, plugin-based software, giving you the ability to generate dynamic threat scenarios with live inputs, perform automated RF verifications, conduct closed-loop feedback, import legacy threat databases so you can test with old, current, and emerging threats, and be seamlessly integrated into the workflow. In the center of our screen, the system under test has 8 different threats around the platform. Here is a waterfall display in Simulation View, which is representative of the scenario we're expecting. Here, we're observing the output of port 1 from our VXGC signal generator, which is going into port 1 of our UXR oscilloscope. Let's observe the RF output of our scenario a little bit closer. In the time domain, you can see that all 8 pulses are being generated at the same time, pulse on pulse. And you can see the amplitude decreasing while the pulse width is increasing. You can also see here in the frequency domain, all 8 signals are centered around a carrier frequency of 10 gigahertz. I will now change the measurement software over to the VSA pulse analysis software. The UXR has leading-edge technology with real-time DDC and variable length segmented capture. It can automatically capture the on-time of the pulses and keep timestamps of when each occurred. This means it can capture realistic EW scenario times lasting seconds or even tens of seconds. Here, we're looking at the output of the VXGC. You can see here the frequency and time domain views and the waterfall of the spectrum. Notice the same patterns with the various modulated pulses that we had simulated with the Simulation View software. The VXGC we have here today can be configured to output on all 4 RF channels, both simultaneously and independently. All channels can be independently tuned to produce high-density simulations, or each can be tuned and synchronized to generate an angle of arrival AOA simulation. So let's take a look at an example. I've now turned on all 4 RF outputs. I've duplicated the same 8 pulse emitter scenario across each port. Here on the UXR, you can now see that I have turned on all 4 channels. All VXGC outputs are generating the same emitters at the 10 gigahertz carrier frequency. We can now use the Simulation View software to incorporate kinematics of our moving system under test or moving threats. As the system under test changes location, the Simulation View software will automatically compute and generate the angle of arrival on each antenna port by changing the relative amplitude, phase, and timing. Thus, we can use the 4-port VXGC as a 4-port angle of arrival simulation system, all in a compact footprint. Alternatively, it can be used to generate very high-density threat environments. As I mentioned, each RF output can also be independently tuned. So here, I've now changed the carrier frequencies of each RF output port to 10 gigahertz, 17.5 gigahertz, 7.5 gigahertz, and 12.5 gigahertz. You can see on the UXR that I've changed the center frequencies of our measurement windows to match the RF output frequencies of 10 gigahertz, 17.5 gigahertz, 7.5 gigahertz, and 12.5 gigahertz. Each of the source outputs have emitters across 2.5 gigahertz of spectrum. This is effectively 10 gigahertz of spectrum to work with coming from a single instrument. Traditional test systems would require 4 times as many sources and substantially more lab space. Here at Keysight, we've found ways to make your workspace more efficient by offering superior performance in a fraction of the space. The scalable architecture of the VXGC also allows us to synchronize it with additional sources to increase AOA ports and/or simulation density. It is a new addition to our EW portfolio and can also be integrated with the VXG signal generators to meet stringent test requirements. No matter what your test requirements, Keysight can address them with superior quality and unrivaled customer support. For more information, please contact your Keysight representative.